I am Jasmine Toole, and I am the Soils Technical Lead and Knowledge Exchange Coordinator on the Centre for High Carbon Capture Cropping. This is a 4-year multi-partner DEFRA-funded project, and we are about a year and a half in, and we have quite a few of the project partners on the call today. So if you have any questions that I can't specifically answer, we have a lot of the partners that could. So the project is looking at increasing resilience in farming and carbon capture within the crops, and we're looking at 4 main cropping options. So we've got biomass crops, miscanthus and willow, we've got cover cropping, herbal lays, and we're looking at fibre crops, which is primarily why we are here today, because we don't only look at the crops, we're looking also at the market options we've got to create high value outputs and products. So we're really lucky today. We have some great speakers. We've got Jon Horsfield, who is the hemp production manager at Harrison Spinks. And Harrison Spinks are luxury bed makers. They have a manufacturing facility in Leeds, and they use a lot of natural fibers in their products. And we also have Alex McLeod from IndiNature, who is the CEO, and we have Sam Bornba, who is a co-founder and former business development officer. And IndiNature produce bio-based insulation products, and they are based in Jedburgh, which is in the Borders. So today, the running order, we will start with a video which showcases the manufacturing within Harrison Spinks. The videos that we see today have been produced by the Biorenewables Development Centre, who are a project partner. And we'll follow the video by hearing from Jon, and then we'll move on to the video which showcases the processes inside the IndiNature factory, and then we'll hear from Alex, and then we will open the floor for questions. So hopefully technology is going to be on my side, and I'm going to be able to share my screen and show you the video. So I will do that now.
In my opinion, the most important part of the process is a thing called retting. Retting is a process. We are basically using nature to move those glues, those lignins that hold that plant together. There are different opinions on how long you ret. It's not as simple as that. The weather's going to have a pronounced effect on how long you need to ret it or how long you will ret it. When I think something's retted enough, I want to be able to grab it in my hand, give it a shake, and start to see the wood and the fibre coming out. That, for me, is close to being retted enough, but I would like to see it a little bit more retted. It's a little bit tough, but I can see the fibres are already starting to come out and the wood's already starting to separate. Why I believe retting is so important. Hemp is a carbon negative raw material. Every 1 tonne of hemp we grow will have absorbed 1.62 tonnes of CO2. What that means in essence is approximately 43% of hemp is atmospheric carbon. So you start from a really, really great place. So as a business, when we remove nylons, polyesters, foams that basically come out of a hole in the ground somewhere in the world and replace it with a natural product, is a huge step forward. And what we start to actively do, we'll make our products out of atmospheric carbon. But if you're honest, every step you put this through, anything that has an energy cost is taken away from that carbon negative head start. Retting has very little energy cost. And if you ret just for 2-3 weeks longer, you're going to need less machines to process it. You're going to have to put a lot less energy in. You'll also be able to process it quicker at greater volumes, so even your costs go down. So the first machine we use to process the hemp is the shredder, which does what it says, it shreds. So initially we struggled to find a reliable way of opening a bale of hemp. It's so strong. We tried traditional bale openers from agriculture, but the hemp used to just destroy them. So we went out, we bought the shredder. It's super simple, but mentally strong. It was being used to reprocess armoured electrical cable. So we can basically take a segment of the bale, drop it in the top. You've got a solid steel roller. On it, you've got hardened steel teeth. Behind that, there's fixed teeth. The roller rotates, the teeth interlock. The gap between the edges of the teeth is less than 0.2 of a millimetre. Then you've just got massive hydraulic rams. Between them, there's a block of steel. Whatever you put in that shredder is going to get pushed against that roller till it's gone. And it's just super strong, super simple. We could put a whole bale in at once. We don't, because it'd put far more material through than the other side could deal with. From the shredder, we then come on a conveyor, which drops into this. These are the best example of what we had to do as a business to process hemp. So when we started this journey, you're talking about 15 years ago, you couldn't ring somebody up for a hemp line. It wasn't something you could just go out and buy. So we basically worked it out for ourselves as we went along. This is called a straw walker. Yes, its first name is Luke. And it's basically a shaker. Inside there's 6 what we call box sections, big log oblongs. They're hollow, they're perforated. They have the little triangles on the top. When it runs, they pump like this, and they basically shake the hell out of the hemp straw. The better retted the hemp, the more effective the straw walker is. It's just encouraging that fibre and that shift to separate. There's no cutting, chopping, crushing. It's just a shaking motion. It runs off one motor. It uses very little energy, and it's the insides of old scrapped combine harvesters. And we build these, and they're just really reliable. It just starts to shake out loads of material, the shiv and small bits of fibre, which we can then take where we want and use appropriately. So here is some of our finished hemp fibre. You can see how important retting is in the difference in colour. This is probably been retted for about 3 weeks longer than this hemp. That bale is not as clean as this bale. There might be something like 5% difference in the amount of shiv that left in the fibre. When you look at the fibre, you can feel the difference. That is softer, that is coarser. We can use both, but that has been a lot easier to process. And sometimes if we don't ret it quite enough, we can still process it, but we might have to put it through the machines twice just to get that cleanliness down. For me, retting is so important. It's all well and good as using hemp as a sustainable raw material, but if we're not honest and we don't use as much as the plant as possible, are we really being sustainable? Our aim is to use the whole of the bale. We do lose little bits, and when we first started processing, we were quite shocked about how much of this fine material we were losing. I mean, it was quite a lot. We lose less now, but we still lose some. So we went out, we bought what's called a centralised dust plant. We can send all this material as we move it to one location. We then feed it into our briquette machine, and then purely from hydraulics, we compress it, and we've now got a biofuel. So this now provides hot water and heating for this site, which is also got a visitor centre, and it's a hotel and a wedding venue. Now, not all biofuel's equal. The theory behind biofuel is you chop a plant, you burn a plant, you regrow that plant. If you chop a 50-year-old tree down, you could argue it's going to take 50 years to close that circle. Hemp's 12 months. So we could take all the hemp we grew this year, we could burn it, use it as biofuel, and regrow it next year and hit that true neutral point. The other argument is hemp will give you 4 times the biomass per acre than you will get from growing trees. So you could build an argument that an acre of hemp protects 4 acres of forest. One of the products we produce that we never actually meant to produce, so we produced it by accident, is this hemp dust. If you squeeze it, you can see it wants to hold a shape because there's quite a lot of oil in there. Now, we get this by using a thing called a de-duster. The de-duster is there to clean up the hemp shift, so that the wood that we're bagging up for animal bedding, horse bedding, is cleaner and has less dust. We gave some away a few years ago, well, probably about 7 or 8 years ago now, to a company called Adaptivate, run by a guy called Tom Robinson. They now make a natural sustainable plaster, which is called Breather Plaster. They're winning awards, doing really, really well. So this all gets bagged up and goes off to be turned into plaster, which you could use on a castle because it's a sustainable, breathable material. So and you're also locking up carbon at the same time for the long term. It works really, really well. Why do we use hemp fibre in a mattress? It's a green alternative. It's a sustainable replacement for nylons, polyesters, foams that come out of a hole in the ground. We grow this outside the back door. We're 70 miles from the factory in Leeds where it gets turned into mattresses. The best thing about hemp fibre in a mattress, it's not a green compromise. So the analogy we tend to use is if you've had a bath or a shower and you've got a choice, there's 2 towels. One's nylon polyester based, one's cotton based. Which one are you using? You're going to use cotton because it's going to dry you, you know it's going to dry you. Hemp is even more absorbent than cotton. So hemp fibre can absorb 10.1 times its weight in water. It's super absorbent. And by taking that water away from them, keeping them dry is what gives you temperature regulation. So it keeps them cool in the summer, keeps them warm in the winter. And that's why natural fibres make for better beds.
Thank you for the video, Jon and Biorenewables Development Centre. So Jon, is there anything you'd like to say after the video, any bits that you've missed?
I think a bit of honesty about why we actually started what we were doing. I think our aim as a business wasn't initially to be, sustainable as possible. I think it was actually to make better. Well, it was to make better beds, and it goes back to that natural fibres just work better in beds. Hemp's hygroscopic, and it's how natural fibres deal with moisture. When we started to understand the CO2 involved and the carbon involved, then it became more empowering, and that's when it becomes, more meaningful for me personally. I think the idea that you can actually not just make things more sustainable, but actually start to make products out of atmospheric carbon, I think is when it becomes really powerful. And if you're doing that without even compromising on your product, and the one thing when anybody asks me about, I want to process hemp, I want to work with hemp, I always try and encourage them to work back from a product. Have your product in mind. What's it going to do to your product, how it's going to improve your product. And I think that's where we become successful, because we had this prestige product that was already made home from hemp for hemp, and hemp just improved it, just made it a better product. And I think that's key to our journey. Is there any questions? Because it might be better answering questions.
So we can move on to the next video and we can save the questions for the end, Jon, if that's okay.
Sorry.
No, that's absolutely fine. Okay, right, hopefully this time we'll get audio straight away. Sorry about last time. Right, thank you, Jon.
Materials. We were an Edinburgh-based startup company, but we always knew that the manufacturing operation needed to be part of the rural economy, and we're very fortunate in Scotland. We have the Scottish Borders with an incredible manufacturing heritage and textiles heritage, and also farming heritage as well. So when we were scoping locations, we finally found Jedburgh in the Scottish Borders with an incredible local workforce. About a year before we set up in the Borders there, about 100 jobs were lost on this same site. If you Google industrial nature, you'll find us. You'll also find lots of pictures of old industrial sites being overgrown by nature, and that was part of the concept behind the company, was that we didn't just want to manufacture materials, we wanted to contribute to a natural industrial revolution and to really make sure that we've got a just transition with a new clean tech and climate focused company that can add to community impact as well. So IndiNature switched on production in October 2022, and the UK is quite a long way behind other European countries who have been farming industrial hemp and making use of this crop for a number of decades now. And it's a traditional crop that a few hundred years ago, every farmer in the land would have been mandated to grow it. But now, Yorkshire is currently the hemp capital of the UK, and IndiNature has been working for 5 years with East Yorkshire Hemp to really start to regrow that supply chain with others across the UK now. So every single IndiNature product that's been manufactured since October 2022 has used Yorkshire's finest industrial hemp, and we're going to need an awful lot more if we want to really change the world and fill the capacity of our production line. So part of the plan has always been to start to activate that local supply chain for industrial hemp and look to influence change and reform in legislation. And we're really delighted to have had successful trials in Scotland. That we have a huge number of local farmers really excited and interested to grow industrial hemp again and add it back into their farming rotations as a crop that can help to improve soil health, improve biodiversity, and also their yields on the following crops as well. In establishing the local supply chain, there's always a chicken and egg scenario. So IndiNature finally getting up and running and having some demand for supply means that the farmers locally can consider planting and growing industrial hemp again because IndiNature is there as a major customer. When industrial hemp fibres arrive from the farms into our bespoke canopy, they're offloaded, and we have an inbound quality check procedure, checking for the specification, everything from weight to fibre length to humidity. And we bring it into the first part of the process, which is to open up the bales. A lot of the fibres are quite compacted when they come from the farms. We have 3 different bale openers at this stage of the process, one for industrial hemp, one for other recycled fibres that we can blend into the materials, and one for the bico binder that we need to really help the products to set and to hold together. This sort of process is very different to manufacturing other kinds of insulation where at the very first part of, say, a mineral wools process, this would be big blast furnaces using huge amounts of energy to melt rock and glass, whereas here it's a very cool process, teasing out the fibres, getting them nice and consistent and ready to be worked with and to use in the manufacture of the various different products. It's a little bit like making a cake. We're blending the different fibres and materials, including the binder, which is then nicely evenly spread all the way through. It's an air lay process, which has again been innovated over the last 100 or so years. And by the time the fibres are blended together, including the bico, through the air lay tower and condensing tower, they then form a nice even mat that goes through a sheet former, which forms the material into the right height and density, laying the fibres together in a really uniform and consistent way, and making sure that we've got the right amount of material, which then traps the air into it to form really, really good insulation. We apply additional fire retardant, which is an inert salt to the material, both throughout the material and a surface application. And after being formed into the right height and shape, we then put it through a thermobonding oven. It all moves fairly slowly, about 1 meter per minute. And as the material goes through the thermobonding oven, the binder melts at a very, very low temperature, somewhere between 110 and 130 degrees C, so less than your oven at home. And as it comes out of the compression section at the other end of the oven, which is about 20 meters long, the material has condensed slightly and is in the final formed shape that we want it. It then goes through a cutting and automated packing and stacking process with 5 rib saws and a flying rib saw, cutting the material to the different shapes and bespoke sizes to suit the different industries and applications in construction. And we automate the packing and stacking into routine packs with a quick heat seal and a very light wrap of plastic to protect the materials in transit and make sure they arrive in good shape. We have a carbon management plan on site as well, which means we are trying to reduce the number of microns, the thickness of the plastic that's used. We're looking at bio-based plastic alternatives as well. And we're also monitoring on every batch, on every shift, the energy usage across the whole line in terms of electricity and energy, and a small amount of LPG gas in the thermobonding oven, which is our only Scope 1 emissions on site. Before any of the materials leave the facility, each batch has a quality control process of a number of in-house checks of our thermal performance of the materials, fire resistance, density checks, dimensional checks, and so on. The fire checks are really important. We have a firebox in the quality labs, and many of our customers don't realise that we check every single batch and that we make sure it is compliant with building regulations and reaction to fire. Natural fibres have a great reaction to fire. They smoulder very slowly. They don't ignite and combust. They have a very low volume of smoke produced, and they have no nasty chemicals coming off them, no VOCs. They're very natural. Reaction to fire test, the British standard test, exposes the materials to a naked flame for a certain number of seconds, allows them to smoulder, and if they don't pass a certain point on the material, then it's a pass at a certain level in the materials. They do overall combust, so in the fire ratings, the reaction to fire is a Euroclass E currently for the materials, which is completely fine for buildings up to 11 metres in Scotland or up to 18 metres high in England, to be used in a range of different applications. We also use our quality labs for R&D as well, constantly innovating, constantly learning how to improve. Over the last 2 years, now that we have the IndiNature mill in place and the production line, we've been learning what we can make with the facility. And so we've been innovating a lot of different products, reducing the density, reducing the weight of different products for adding into lofts, for example, with IndiLoft. We've achieved the first British Board of Agreement certificates for IndiTherm, which is a pure hemp insulation at 45 kilogram density, really durable and great for use in buildings where you want to have a maximum biogenic carbon capture. And we've just also secured a British Board of Agreement certificate for IndiBreathe Flex, which is a blend of industrial hemp with recycled jute. Natural fibres are also fantastic for acoustics, so we have great acoustic results for all the different products, but exceptional results for IndiSilence, which is our new acoustic range, which blends recycled cotton with the industrial hemp. And IndiSilence is now produced as an alternative for acoustic partition roll for internal walls and floors, and is the first bio-based material to gain a Quiet Mark certification from the Noise Abatement Society. So we're really excited to be launching that as a new one in 2025. Several new products are about to come to market in 2025 as well, including high density industrial hemp boards, which we can now make and manufacture thanks to new equipment. So the number of products for construction is expanding, and we're also now making products for mattress and furnishing sectors, for automotive and biocomposite sectors as well. We're exploring all sorts for horticulture and geotextiles. So it's a really exciting time. Now that we have the IndiNature mill in place, we can explore with partners how we can revolutionize different industries, different markets with healthier materials. It's really important to us that what we're doing is we're bringing good quality and healthy materials into the supply chain, so people can build healthy buildings using healthy materials. So from field to factory to the front line of climate change in the built environment, we're trying to bring the best materials.
So thank you again to IndiNature and the Biorenewables Development Centre for the video. A lot of that content was captured on day one. We actually got to go to visit the factory ourselves to see how it's all done. So if you get a chance, well worth a visit as well, like Harrison Spinks, really fascinating. So Alex, have you got anything to say, please? Okay, I'm able to unmute you. Alex?
Am I unmuted yet?
Yep, you're all good.
Okay, very good, thank you. Maybe just sort of quick introduction. So I've been leading businesses in construction materials for over 20 years, and most of that leading mineral fibre businesses. And I guess I've been on a journey to understand the importance of both innovation and the environmental impact of sort of building materials and how they're manufactured, sort of in on the built environment going forward. And where IndiNature scores sort of exceptionally well is in the fact that our products are carbon negative, which the video sort of alludes to. We have had a life cycle analysis completed, and we have an EPD coming very soon. Our net position is that for every kilogram of product we produce, we save half a kilogram of carbon, or put another way, half a kilogram of carbon is embedded into whatever sort of application our product goes into, construction or furnishings. I think that's really going to become increasingly important, going forward. I think also another thing is that Sam, our co-founder, one of our co-founders, alluded to in that video, is the importance of breathability. And our products are breathable, and what that creates is a warm environment in winter and a cool environment in summer. And we see that as becoming increasingly important. There's a metric called, for those interested, called specific heat capacity, which attempts to measure this, and our product is best in class in that respect, which creates as Sam alludes to in the video, a healthier environment in within the building. Perhaps the final point I'd want to make is around acoustics, where our products are exceptionally good on acoustics. In a number of situations, you need half as much of our products as you do of mainstream insulation materials to achieve the same acoustic performance. So there are some significant benefits to using our products in construction, and as Sam in the video alluded to, in furnishings and other markets, where we're exploring and developing new products for 2025. Perhaps since Sam's on the call, Sam, would you like to add anything to that?
Well said, Alex. If we've got another minute or so, Jasmine, as well, that it's ridiculously exciting time for the UK now having this in place. And as Alex said, some of those benefits of biofibers, natural fibre insulations are now certified and available for different markets. And that's a huge moment. And I think that the regulatory side of the markets is only just catching up finally with where we are. So there's still work to do, but it's really exciting touch point, I suppose, for being able to finally utilise industrial hemp and other fibres for all those benefits Alex was saying. So yeah, looking forward to discussing.
Thanks, Sam.
Thanks, Alex. Thanks, Sam. Especially breathability with the warmer climate that we're moving towards. That definitely seems like a massive asset to have in buildings. So we have a question from Charles, which is for Jon, and he is saying or asking, which hemp variety are you growing, and what are the challenges you experience, and how would you like to see the varieties perform better?
Well, the variety is cannabis sativa, but the actual, we use Futura 75, which is the main one that we've grown. As far as challenges, it's the weather, basically. We've had some really wet springs. We've put it in the ground and we've not had any rain. I mean, there was one farmer, he actually planted it early this year, and he ended up with the best crop. He took the risk and actually put it in the ground in the April, which you wouldn't normally do because it's not frost tolerant, so you generally don't want to risk coming across the frost. But you know, we talked about it and we thought, when did we last have a frost in April? And you know, I mean that's part of it though. I think we're all going to have to start adapting and you know, just looking at where we are and maybe not plant everything at the same time, maybe spread the risk. I mean, in cold countries, we don't even they don't ret it on the ground, they leave it still up all winter. You know, and if you look at some of the stuff from Ukraine and Poland, where it's basically frozen for 3 months, it's wonderful stuff. Some of their hemp, you wouldn't ret the crop on the ground all winter in the UK because you probably get weeds growing through it and you struggle. I don't know really. I just think it's like anything. You go look at where you are and spread your risk.
Mm. So if you're not able to ret on the ground, where would you ret instead?
I think in the UK, you're always pretty much going to be retting on the ground. I mean, traditionally, historic-wise, we used to have things called retting pools and retting ponds, and you'll still find them at old monasteries and places like that. But the issue with that is you get a lot of wash-off, you get a lot of unpleasant water. We ret on the ground because it's the simplest way of doing it. In a lot of ways, it's not the most reliable. And you've got to be a bit brave as well. You know, if someone's telling you that it's going to rain for the next 3 weeks and you're 5 weeks into retting, you might have to bail it then and just, you know, you're going to have more fun processing it. You're not going to be able to aim for an ideal and get that ideal every time. I mean, I think when you work with a natural product, you've got to build your machines in a way that they can deal with it. But you've also got to be aware that you're trying to aim for the best possible outcome. The difference for me is, to get this right across, is if I retted something for 5 to 6 weeks and went to process it, I'd be happy if I could get over 10 to a week through. If I was processing something that I'd retted for 8 weeks plus, I'd probably process 20 tons a week. And that, you know, that's a massive effect on your costs and your production. I don't think every fibre is suitable for every product. I think some products you'll want it less retted. You'll probably have to put more work in it to get the fibres out because you want more of that fibre strength. I think the fibre gets weaker the longer you're retting it. So I think with some biocomposites, you'd probably approach it in a different way. But I think for what we do, non-wovens, you know, retting's your best tool for me personally. I think it's a great machine.
Whilst we're on retting, I've got one question, which is, can you over-ret? And then how does retting differ for shib versus fibre?
As regards of over-retting, I've never, ever been not able to process hemp because it was over-retted. We once got some from, we once had a crop we couldn't bale. We didn't bale it till that really hot February. I don't know if you remember, we were all sat outside in 20 degrees. We actually baled it then because the winter was just a washout. We lost lots of shib, so your yields, you know, very, very low. But the fibre it produced was wonderful, lovely and soft. It wasn't strong. It's some of the only fempi fibre where I could actually snap it. But you could use it as a non-woven, and you know, it just flew through the machines. And when it got to Leeds to make mattresses, the lads loved it. You know, because there were no shib in it, it wasn't causing them problems. I've had lots of hemp I couldn't process because it was under-retted. You know, and I mean, I've nearly done this for nearly 15 years. And a lot of people come unstuck because they put in these wonderful lines and then they don't ret the hemp enough. And we've had crops where people have baled it when they weren't supposed to bale it, and it's biofuel at that point. We can burn it, we can use it for heat. It never goes to waste, but to run it through the machines, it would be an absolute nightmare.
Great, thank you.
No.
So I'm not sure if this is for IndiNature or for Harrison Spinks, but you're both welcome to answer. So Helen has asked a question about the volume of crop needed to meet the demand and how we can achieve meeting that.
You can go first, yeah, please.
Well, how was I going to hand it to Sam?
Yeah.
I've got a figure in my mind, but it's probably Sam's been sort of living and breathing this for several years. So, what the question is how many tons of product do you get per hectare, and I can work it out from there. If that makes sense.
Yeah, and I mean, and in terms of, as Alex knows, one of his first things he did when he came into the facility there and assessed was the capacity of the line. What can we make and how much can we make? And across all those different markets, we need different quantities of hemp and so on. So at IndiNature, we have just the one line at the moment, and that's got between 6,000 and 7,000 ton capacity per annum in terms of volume. If we were just putting hemp through that, that's what we need. But it's not just hemp; we have other materials going through it. So at the moment, we are only just starting out first couple of years of production. So we can basically survive on between 400 to 600 tons per annum from Yorkshire at the moment. But that's why it's been so much part of the plan to really work with local farmers closer to the borders site, and Ian Fullerton and the SAC consulting team have been fantastic in stepping forward and trialing, basically growing a new crop and adding that into the rotations, and how do we make that more sustainable and grow it steadily with us as we make sure that the market is there and the demand pull matches supply chain. So that journey is really important. We all go on that together, because we're changing a currently linear economy into a more circular bioeconomy, and that takes time. So in terms of filling the capacity of the IndiNature line, there's enough supply at the minute, but we'll outstrip that within the next couple of years. So that's really, we've got the next 2-3 years is the time to be growing that supply up to more like 2,000 tons of material per annum, and then up and on beyond that as the market pulls it through. So yeah, it's there's plenty of scope to grow more as the demand increases for bio-based materials, not just in construction insulation, but across all those different markets. So getting the unit economics right is really, really key, and that's where, again, Alex has been really supporting, making sure we've got the right balance, because we have to be commercially competitive at all scales and make sure that everybody's getting the right numbers to make this new crop balance the books. So I don't know if you want to add something, Alex, there.
Just roughly speaking, if you convert that into hectares, I think that's probably about our capacity in factoring in a percentage of use of other sort of non hemp materials. I think now that the volume we'd be looking at is about sort of say 600 to 700 hectares, something like that. However, that's just for one factory, and then in the context of where IndiNature sits in the overall sort of market for insulation, we're probably about 2%. So at this stage, so if this is successful and takes off, we're looking at a sizable sort of a hectareage that would be required just for fibre for construction materials.
Can I just when you guys are talking about weight of hemp, you're talking weight of hemp fibre, aren't you?
Yes.
So for anybody listening, if you take a ton of hemp straw and process it, you're probably going to end up with 27% fibre. So you'll end up with about 270 kilograms of fibre as an average. So when you're thinking about volumes, if you need, say, 7,000 tons of hemp fibre, you're going to need to multiply that by 3.5 to get an idea of the amount of hemp straw you want.
Yeah. And the importance of that, what you just said there, John, is of course that we need to be thinking about sort of finding markets for that other 70%. Some of that is obviously animal bedding at this stage, but we're looking at how we will utilise more of the plant in higher density materials for walling systems going forward?
Yeah, I think if you're not going to end up using everything, you know, the worst case scenario, you turn it into biofuel. You know, because at the end of the day, it's still going to turn out carbon neutral. I think biochar is going to be quite interesting, you know, because that's something you can link in with farmers as well. And you know, if you that's going into the ground, that's another way of locking up carbon for the long term. Building, construction, just as you know, hempcrete is still a great product, and some of the innovation in that. I mean, we've sent loads to South Africa. We've got another load going to Chile. So you know, it's a little bit ironic that Farm in Yorkshire sending it all over the world. But yeah, I think long term it will all get used.
That's great. Thank you. Stuart, you said that you have a question. Would you like to put your mic on?
Thank you, Jasmine. Yeah, it's a question for both John and Alex, really, and that's about sort of end of life for your respective products. So when your mattresses have sort of served their useful life, and how long is that? Or when the insulation has served its useful life, and again, how long is that? What can you do with the products after that? How can you recycle them?
Well, that's sort of the next big process for us. So the site I'm on, we've actually got. We're in the process of starting to put in a thing called an autoclave, which is, think of it as a pressure cooker, basically. It's a way of cleaning previously used fibres and materials. Now, your mattress, 7 to 10 years, people tend to use a mattress, and then they're looking on changing it. Recyclable, we could use recycled mattress fillings. The issue you've got, it's like making underpants out of recycled underpants. You can make them completely clean, wonderful, but it's not an easy sell. So traditionally, you know, beds aren't an easy thing to recycle. So we as a company, we've gone away from glues. You know, our product's going to be fully recyclable, and that's part of our, you know, our consideration when we manufacture them. We can use that fibre in other products. It might become underlay. I don't know what it become, but the aim is nothing to landfill. Okay.
Perhaps if I can just build a little bit of that. So as John said, we replace our mattresses every sort of, let's say, 7 to 10 years. We buy 6 million mattresses a year. So by definition, we scrap a similar amount every year. One of our major funders, Zero Waste Scotland, when I asked them, they said their biggest headache right now is what to do with mattresses. And if you look at every skip in sort of around towns and cities, invariably you'll find a mattress in there for a reason. One thing that and it's very early days, but we are looking at is whether we could use some of the materials in sort of mattresses and repurpose them for acoustic insulation within the automotive sector. That's done in Europe already, and we think that's something to explore in the future. So that's one. In terms of construction materials, actually, because there are so few additives, our product is relatively easy to recycle and reprocess at end of life. We're a startup, so we've not really got to end of life, but our planning is around how can we sort of recover sort of our waste, our material, and basically in simple terms just reprocess it. Any waste that we produce in our factory, we reprocess. So we've got a complete closed loop already within our factory, but we don't believe it would be particularly difficult to technically reprocess sort of material at end of life. There may be some challenges with the logistics of how you recover that from site, but there are other manufacturers who've been able to solve that. Example, plasterboard, quite successfully. So that's not something that I'm particularly concerned about. That because of the simplicity in the way our products manufactured.
There's also another consideration. Our products, because they're made of natural fibres, you know, it's like a plastic bottle is recyclable, But if you sell that bottle to somebody who can't be bothered to recycle it and just chucks it in the river, it's going to become an issue. When you're making products out of biodegradable materials, natural materials, if somebody doesn't recycle them and they do end up in a river, it's not going to cause the issue, you know, that plastic bottle would cause. But you know, our intention is to own end of life, but you are relying on the consumer, you know, not chucking it in a lay-by and actually, you know, sending it to the right place.
Thank you. We
Thank you
had a
both.
question come in from Axel. So they have asked, what are the main barriers to wider cultivation across the UK and what is needed to overcome them? So, I mean, I would say that the license process has previously been a barrier, but I know that that is becoming easier. And I did spot Lydia on the chat. I don't know, Lydia, you have any comments on that?
Yes, we're very pleased the way that the government and the Home Office in particular has responded to changes in license. So those changes have come about as of this January. So anybody that is applying for a license for the first time will now have those improved situation. So the first one was that before you had a license that lasted for 3 years, and this is now you can have one for 6 years. That makes a lot of difference to farmers because there's a lot of paperwork involved in getting your license. The second change is that you can license your entire farm rather than specifically picking up just a few fields. And they promise hand on heart that they will be lighter touch in terms of whether there are roads and footpaths alongside any of those parts of the farm you want to use. So that enables a proper rotation where it was quite difficult sometimes before. The change that we didn't get, which was to change the maximum THC level allowed in industrial hemp from 0.2 in the UK to 0.3 as it is in the whole of the rest of Europe. And whereas they originally said this can't be considered, that view has changed in the last months to it will now be considered. So we haven't got the change, but we've got them thinking about it. And I think that's a really good step in the right direction. So for any farmers that are on the call that were thinking about it and have been put off by the license, it's definitely worth having a look at the changes. As I say, they are new from this January. And you can also get help from our partners within the CHC ×3 project, from us personally or from our partners at particularly the British Hemp Alliance. I hope that's useful.
Yeah, thank you, Lydia.
Could I add to that as well, Jasmine?
Yeah, of course.
And I think so that Lydia's captured it well, the government stepping up on the farming side, and that's due to a huge amount of work from a lot of people over a lot of time. We also need the government to step up on the market demand side as well, because if that market demand isn't there, then who are you cultivating the land and producing the crop for? So recognising the value and the benefits that Alex was describing, for example, in the built environment, around bio-based fibres and natural fibre products, is something that European governments have done. It's in regulations, it's in legislation in the European continent right now, but we're behind the game in the UK. And adding that in granular detail is really, really important if we're to see the mass widespread cultivation. Otherwise, farmers will be just starting it and only able to use it for a small range of applications. If we want a real change, if we want to address it, the UK is perfect for it because we've got such good agricultural land and we need our rotations to include a crop like this. But we need that further regulatory adoption, really, and seeing the benefits like specific heat capacity being one where natural fibres absolutely win, and our buildings need that for the future. So yeah, that's the other bit that isn't complete yet. That's going to be needed.
You make a really good point, Sam, and I'll add to that. I was at the Oxford Farming Conference this year, and one of the things that was discussed was food quality. And the minister said that one of the changes they're going to make in order to help children have a healthier diet is that there will be a particular change now for hospitals, prisons, and I think he said schools, to use UK farmed materials. And that makes a huge difference, because it's not legislation as such in terms of the license, but it makes a difference in terms of farmers. So what we're going to be doing this year, I don't know whether there's anyone from government on this call, but we'll be lobbying hard for councils to use sustainable products such as the hemp materials that you see in IndiNature, because that would be very easy. It'd be very easy for that to be a use in council and other government buildings, and it would really make a point about, yes, we're not just having our say about sustainability, but we're actually making sure that it does happen. So yes, Sam, I totally agree with you, and we will be pushing hard on that front.
No, Lydia, I'm really pleased to hear that. We're also doing similar. Go back to my 20 years of experience in this sector. Insulation in particular is very much regulation driven.
Yeah.
There is something called Part Z, which is there's a sort of growing body of advocates for recognising embodied carbon within buildings. It's not part of the regulation as yet, and anything we can do to encourage that. So I've today written to Ed Miliband, and the First Minister of Scotland, to encourage, see if we can get we can get an audience at some stage, with both. These things take a long time, though. Got to be realistic about this. Any changes to regulation, one will be challenging to persuade, particularly in the light of this government's target to build 1.5 million homes. I dare say they'll be encouraged to minimise regulation change to achieve that target. But nevertheless, I read a statistic recently that by 2035, almost half of the carbon emissions in buildings will come from the manufacturing processes, and that surely is something which government will need to do. Should be thinking about addressing in the not too distant.
Thank you, Alex. I'm really sorry, but I'm going to have to stop you there, as we're going to be cut off very, very soon. So just thank you so much to all of our speakers today, and for the videos as well. It's been really informative, and the webinar will be shared on the carboncapturecropping.com website to you shortly. So thank you, everyone.